Hello guys, welcome back. In the last lecture, we talked about organic chemistry and organic compounds, and we also made mention of two chemists who were pioneers of organic chemistry. We talked about Jacob Berzelius, and he contributed his quarter by buttressing the point that organic compounds are compounds of living organisms and can only be extracted from living organisms. But then later on, we also made mention of Friedrich Wöhler, who synthesized urea, which is a compound extracted from living organisms, from ammonium cyanate. Today, we define organic chemistry as a branch of chemistry which deals with the study of carbon compounds in relation to hydrogen, sulfur, oxygen, nitrogen, phosphorus, the halogens, etc. So it means that when defining organic chemistry, focus of organic chemistry is on carbon. And it means that organic compounds are compounds of carbon. Now, regardless of whether they were produced from living organisms or whether they were synthesized in a laboratory, they are compounds of carbon. It means that you can't find a compound that is organic lacking carbon, even though 98% of the whole compounds in the world are organic compounds. Each of those guys have carbon, at least one carbon atom in them. And then the question is, why carbon? Because in the periodic table, we have 118 elements in the periodic table, and carbon is just one of them. It is sixth of the 118. And the question is, why are we dedicating a branch to the study of carbon compounds? Why not hydrogen? Why not nitrogen? Why not sulfur? Why not antimony? Why not lead? Why carbon? Now, the reason is because carbon, unlike the rest other elements, show a couple of unique properties. And these unique properties made carbon qualify for a whole branch of chemistry. So it made us cut out one of the four branches we have at this stage, four major branches we have to the study of carbon compounds. And now, these unique properties of carbon include tetravalency, includes catenation, includes excitation, and hybridization. Each of these guys will be discussed in separate lectures so we can understand or have a full grasp of these concepts. Now, it is important to note that not all compounds of carbon are organic. Now, we said that organic compounds are compounds of carbon, and carbon compounds, like in relation to hydrogen, to sulfur, to oxygen, etc. Now, it doesn't mean that when you find a compound of carbon, you expect it to be organic. Okay, we would be wrong making such an assumption. Now, there are actually some exceptions to organic compounds, and the reason is simple. For us to call a compound an organic compound, it means carbon in those compounds must fit or must suit into those unique properties. Now, if you have carbon excluding itself from any of those unique properties, then it will form an inorganic compound and not an organic compound. So, what are these exceptions to organic compounds? If we say not all compounds of carbon are organic, that means we should know that there are a couple of exceptions to organic compounds, right? And what are these exceptions? We'll talk about 4 or 5 of them, and these 4 or 5 of them should materialize in helping us identify inorganic compounds of carbon. Now, the first of them is all oxides of carbon. Now, it is important to note, please take note, that all oxides of carbon are inorganic. All carbonates are inorganic. All hydrogen carbonates are inorganic. All carbides are inorganic compounds. And all cyanosalts are inorganic compounds. So these are exceptions to organic compounds. Hence, they do not fit into organic chemistry. The oxides, carbonates, hydrogen carbonates, the carbide, and cyanosalts are exceptions to organic compounds. So imagine you were given the following compounds and you were asked to criticize them as either organic or inorganic. You have carbon 2 oxide. You were asked to criticize these guys whether they are organic or are inorganic. Now, what is this first guy? Is carbon monoxide. It means from the name, we mentioned it as an oxide of carbon. It is carbon monoxide. So being an oxide of carbon makes it inorganic, right? This is carbon dioxide. It's also an oxide of carbon, which makes it inorganic. This is calcium trioxocarbonate 4. It is a carbonate, right? Making this a carbonate, this being a carbonate makes it inorganic. Calcium trioxocarbonate 4. This guy is magnesium hydrogen trioxocarbonate 4. It is also an hydrogen carbonate, making it inorganic. This guy is calcium carbide. It is a carbide, right? Making it inorganic. This guy was a guy Friedrich Wöhler used in the synthesis of urea. It is called ammonium cyanate. It is a cyanosalt, making it also inorganic. This guy is CH4. It is not an oxide of carbon, as you can see. It is not a carbonate. Neither is it an hydrogen carbonate. It is not a carbide and not a cyanosalt. So it is exempted from the list we have, which means CH4 is an organic compound. Alright, so organic compounds, not all compounds of carbon are seen as organic. Compounds such as the oxides, the carbonates, the hydrogen carbonates, the carbides, the cyanosalts are all exceptions to organic compounds. So can you frame up more examples on exceptions to organic compounds following the rules? I'm sure you can, so I'll leave you guys to do that. So write out compounds except these ones we have on exceptions to organic compounds. In the next video, we want to look at unique properties of carbon. Why do we have a branch dedicated to carbon and its compounds? See you in our next lecture.